What's going on, guys? So today I'm actually really excited. I'm back from vacation. I'm having a good time, and we're starting the cyber defense path. So I'll go ahead and just go through it so that way you guys can see it. So the cyber defense path was requested on the Discord, and you can see some of these I've done, but I've never done this path. It just I guess I did these in the past, and that's why. So it says I'm 13%, but we're going to start on day one. So tutorial, I'm not going to go through that because if you guys know, it's just going to tell me how to basically open a box. We can figure that out. So I'm going to start with introductory networking. So I'm really excited for this path because I really like the junior pen testing path, and I think this is kind of another great path to learn defense. So let's go ahead and hop into it. By the way, guys, I really appreciate how much support we've been getting on the Patreon, everything else. So I'm definitely excited about that. And then today I actually am releasing this video, and then I'm also doing the giveaway on the Discord. So hopefully I'll do that tonight. So this will go up. I don't know what time this will go up, but hopefully you guys will have time to sub. All you got to do is subscribe to the channel and follow us on Twitter. So let's go ahead and hop into this. I'm going to adjust my camera just a little bit. There we go. Okay, so first things first here, guys. What are we going to talk about? The OSI model, the TCP IP model, how the models look in practice, blah, blah, blah. Okay, introduction. So I will tell you the OSI model is something you're going to hear constantly in your career in cyber, in IT, in everything. So just kind of get used to it. I know it's a little bit annoying to learn because it kind of feels like when you're a technical person, especially like me, when like all you really care about, you're like, I just want to get my hands on the keyboard. You kind of forget about that stuff. You kind of start thinking, oh yeah, it's great. But then when you start working in this environment and you start working with IT professionals, they will start referencing the OSI model and you'll go, oh crap, I should have paid a little bit more attention. So go ahead and do with that what you will, but I recommend actually learning it pretty well. All right, so here's the different layers. So they gave you one here: anxious, pale, Shakespeare, treated, nervous, drunks, patiently. Okay, so that one's kind of actually, I don't know. That one seems kind of hard to remember. The one I always have done is starting from the bottom. It's please do not touch Steve's pet alligator. That's the one I've always learned. Physical data, network, transport, session, presentation, application. Please do not touch Steve's pet alligator. That's what I've always heard. You guys can use this anxious, pale one, whatever you want to do. Basically, in my opinion, if you can figure out, if you know the 7 layers, you can figure out generally where things go. That's my personal opinion. Now, I'm not going to read all these and go through it. You guys can read this, but I definitely recommend it because the OSI model is used all the time. So layer 7 here, I don't know why they start up there. I like to start at the bottom, the physical layer, right? This is the hardware of the computer. This is your Ethernet cord. This is your adapter, all that stuff. So this is something physically breaks, right? It's physical. It actually physically doesn't work. You cut a cable, something like that. It's physical. That's what you're looking for. The data link layer, this here, like it shows here, focuses on physical addressing. So it receives the packet from the network layer. So this is when it's coming back down. This includes the IP address, blah, blah, and adds in the MAC address. So that's the kind of the bread and butter here, right? You're getting the physical MAC address associated with it. So now you're going to hop up to the network layer. Now keep in mind, the reason I'm kind of skimming through it is because the OSI model is very good, but nowadays it's a little harder to distinguish parts because switches nowadays can function on multiple layers. It used to be, they'd function on certain layers, but now sometimes switches and firewalls can be on 3 or 4 different layers at a time. So I don't put everything into the OSI model like some people do, but you need to know it. So end of story. All right, so now they're on the network layer. The network layer takes IP addresses from the page and figures out the best route to take. So the network layer is where you're looking at actual routing processes. You're looking at, so it's leaving your router, where's the destination, how's it getting there, that type of thing. Okay, and then the transport layer. So transport layer, it's to choose the protocol over which the data is being transmitted. So this is where you're going to start looking at TCP, UDP. You're going to start looking at how is it going to get there. It's looking at how is it going to transport stuff. That's really the main thing. The session layer, pretty obvious. It controls the session. So if me and you are communicating, we have a session we're working with. the session layer controls that and handles when to close it, things like that. Presentation layer, this is again pretty easy. This is the data, puts it in a format that the application understands. So you receive the packet, you receive everything, and now you open it up on your computer, and it needs to be understandable, right? You can't just open it on your computer with nothing. So the presentation layer begins to tell you, okay, this is the type of information, the format it needs to be in, boom, boom, we need to use this, and let's open up. Perfect. Now, the application layer, this is exactly what it sounds like. It works almost exclusively with applications, providing an interface for them to use in order to transmit data. So this would be your applications. Perfect. We covered the OSI model. So now, here you go. These are simple questions. You don't even need to see me to do this. Which layer would choose to send data over TCP or UDP? Layer 4, and it says it right there. Transport layer 4. Which layer checks received packets to make sure they haven't been corrupted? And that's the data link layer. I'm not going to go through all those. You guys can go through those. You can pause it if you want. I think it's not a waste of time, but this isn't important in this aspect. All right. This is important. Which transport layer protocol would be best suited to transmit live video? And that's UDP, because you don't need to validate that it got there. And what I mean by that is, think about Netflix, think about Prime Video, any Hulu, whatever you use. Think about it. So you're watching a video, everything's going good, and then all of a sudden it gets a little blurry, right? And then it comes back. That is because UDP packets do not have that network. It doesn't have that TCP handshake, and it doesn't have that session established. What that means is, in a TCP handshake, you get a packet. That's labeled 1. Then you get 2. Then you get 3. Let's say you don't get 4. It will sit there and it'll wait until you get 4. If you never get 4, you're never going to get C, 5, 6, 7, 8, 9. It needs all of them to actually start displaying the data. Well, if that were the case, and every single time you dropped a packet, every single time something got out of order, anything like that, you'd never watch Netflix. Your Netflix would just sit there forever until it got, okay, we got 5, so then it'd show one thing. And then you'd wait, and then it'd show one thing, right? So there's millions of packets being transmitted here. So it's okay to lose a little bit of data. Now, where it's not okay to lose data in TCP, which is the session, is when you're transmitting documents, when you're transmitting things that can't have one binary mess up. So think of it that way. When you establish a connection to download a file, that can't miss bytes, right? So you'll establish that connection. That's why a download is going to take longer than if you're just using a UDP and watching something, right? All right, so encapsulation. So this is the process of exactly what we just showed in the OSI model. This is how it works. So here, this is basically what you're going to be doing. You're going to be seeing it in the stage 1. The application layer header is added. So you're going to see this theme. The header keeps getting added, but then it's taking, so layer 7 starts, and then it's going to go down to layer 6, and layer 6 is going to encapsulate that data. And when it encapsulates it, it's going to add its header so that then it can decapsulate it, right? So then it's going to go down to layer 5, encapsulate all the data, go down to layer 4, encapsulate all the data, so on and so forth. So now when it gets to the endpoint, this stage 7 will say, hey, go ahead and decapsulate and unpack and look at layer 6's, or not layer 6, I'm sorry, stage 6's header. And then when you see this is layer 2, I keep seeing stage and getting mixed up. But then when you go to the next one, you're going to see the header for the next one. And it's giving instructions on how to unpack everything so that this process can be reversed in decapsulation. So how would you refer to data at layer 2 of the encapsulation process? So at layer 2, how would you refer to the data? You can see it's frames. So this is a bit important because here it's just data. You're just giving it whatever input you have, data, data, data. Well, now that the data is getting a little bit bigger, we're breaking it into segments to transport. Well, then when the segments get transported over the network, you guys are familiar with this term, you guys see packets. That's where you start seeing packets on the network, okay? And that's pretty good. That's pretty easy. So then from there, after the packets, you're going to see frames. And after frames, you have bits. And bits are what you're going to see, actually the ones and zeros that are being sent across a network. So keep that stuff in mind. How would you refer to data at layer 4? And you can see here, layer 4, datagrams, segments, datagrams. So Then what process would a computer perform on a received message? So the exact opposite of encapsulation, decapsulation, or de-encapsulation, whatever you want to say. All right, which is the only layer of the OSI model to add a trailer during encapsulation? And you can see it's the data link layer, and you can see it says right here, data link, header, and trailer are added. Boom and boom. Okay. And then does encapsulation provide an extra layer of security? A or nay? And A, because you have to break all that down. So it's a little bit more security. Now, would it be that difficult? Probably not, but it's still a little extra layer. Okay. Boom. All right. So TCP IP model. Before we get into the actual TCP IP model, guys, I want to give a huge shout out to the sponsor of this this YouTube show, whatever you want to say, whatever we're calling this. But basically, this is brought to you by Manscaped, guys, who is the best in men's below-the-waist grooming. Now, I'll tell you guys, this product has precision engineered tools for your family jewels. You know what I'm saying? So Manscaped's Performance Package, which is what they sent me, which I actually really recommend. I was a little bit skeptical. I'm not going to lie, guys. They sent me this awesome bag. They sent me a T-shirt, ball deodorant, which I didn't know was even a thing, but I will never not use it now. Trust me, if you have a girlfriend or a significant other, they will appreciate that. And then they sent me, obviously, their main product, which is the 4.0, the trimmer, but they also sent me the nose hair trimmer and stuff, but I have not used the nose hair trimmer and things like that. But I will tell you guys, I'm going to be honest with you, all right? This is just me personally. I stopped trimming certain area a while ago, years ago, mainly because I cut myself once, okay? If anyone's ever bled down there in their family jewels, you know what I'm talking about. You will never want to experience that again. It scared the crap out of me. And so when that happened, I was like, nope. I'm not doing it. I'm not risking it. And I kept seeing Manscaped all over the place, and I was like, I'm still skeptical. No chance. Like, I don't know. And then they sent me this bad boy, the 4th generation trimmer, and it has this cutting edge with a ceramic blade, and it's supposed to reduce nicks and reduce this, and I thought, no, whatever. But I'm telling you, I did it, and I purposely got close. I said, I'm risking it. I got to give it a shot because I'm not going to get a sponsor and broadcast a product that I don't believe in, especially if I'm claiming that I'm not going to get nicked and things like that. So I will tell you, I used it. I now use it every day. I will never not use it. This thing is incredible. And not only that, but you can use it in the shower. You can use it pretty much wherever you want. I mean, I use it in the shower every day. It's never caused me any issues. So it definitely is waterproof. The trimmers, the Lawnmower 4.0 trimmer helps reduce nicks, like I said. That's awesome. And then it actually, one thing that I didn't realize that I think is really cool is it reduces ingrown hairs and grooming accidents, which, like I said, is just a game changer for me. I will never not use it. So if you guys want the same product and want to check it out, code Stuffy24. When you do that, you will get free shipping and 20% off, which is freaking awesome because that makes it like basically cheap enough that it's a no-brainer, right? You have to do it. So I definitely recommend it. That is our sponsor for today's I keep wanting to say podcast, even though this isn't a podcast, but to today's YouTube video. And you're going to keep seeing that be read, but that's okay because I actually really believe in it. Like I said, I've had a couple of offers for sponsorships, and some of the products I didn't believe in, so I didn't take them. And this is one of the few products that I genuinely believe in. And as we know in IT, unfortunately, the majority demographic is men, so it's a no-brainer for me as well. All right, let's get right back into it, guys. All right. So here we go. The TCP IP model. What is the difference? Basically, the TCP IP model you see breaks it down into 4 layers instead of the 7. All it is they took the OSI model, boop, and they linked some together. The application, presentation, and session are all in the application layer in the TCP IP model. Transport and network, the transport's the exact same. And then the network, they're considering the internet layer, right? And then the data link and physical is the network interface. So you can see here, they're going to talk a little bit about the TCP three-way handshake, and I've covered this a lot on this channel, and it's pretty important, especially to understanding I've never seen that. That's actually pretty funny. So you have the SYN-ACK, and the ACK. What does that mean? I think it actually stands for synchronize. I used to know, like, memorize, like boom, 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 but I'm pretty sure it's synchronized. So you're sending that and you're saying, hey, I want to connect to you. I want to talk to you, right? Well, they have to send back, hey, I want to talk to you too, and acknowledge yours. So they're saying, hey, I want to talk to you too, and I acknowledge that you want to talk to me. And then you send back, oh, I acknowledge that you want to talk to me. So now you guys have that three-way handshake where now you sent a synchronized to them, they sent a synchronized and acknowledge back, and then you sent an acknowledge back. Whoops. And now you guys have that session open. You have that connection, and until one of you closes it, you guys can send back data back and forth, and you guys already have that session and that connection open, and you guys will be able to just continue to talk in that session, and the session layer will handle that. So which model was introduced first, OSI or TCP? And you can see the TCP IP was introduced first, and then it was expanded with the OSI model. Which layer of the TCP IP model covers the functionality of the transport layer? The transport layer, right? Like I don't understand some of these questions. Like, I get the question, but like, which model covers the functionality of the transport layer? The transport layer? Like, what a waste of a question. Which layer of the TCP IP model covers the functionality of the session layer? So this one makes sense because this one isn't the session layer because there is no session layer in the TCP IP model. It's the application layer. Okay. So the network interface of the TCP IP model covers the functionality of two layers in the OSI model. Okay. These are data link and physical. So like we said up here, data link and physical are all in the network. Just a little different, but same concepts, right? So now which layer of the TCP IP model handles the functionality of the OSI network layer? And that's the internet layer. What kind of protocol is TCP? That's connection-based. UDP is connectionless. What is SYN short for? Oh, it is synchronized, so I had it right. What is the second step of the three-way handshake? That's the SYN-ACK. And then what is the short name for the acknowledgement segment in a three-way handshake? And that is the ACK. All right. So now that we got the boring stuff out of the way, let's start diving into this. Let's start seeing what tools we need. And I'll tell you guys, a lot of these are very basic tools that a lot of people probably are going, oh yeah, I've seen them 100 times. But I can't stress enough how many times I've used these, even in day-to-day life, to just go, oh, let's troubleshoot something real quick. Boom. And that's simple as that. So the ping command. What does the ping command do? All right, so it says right here, it's used when we want to test whether a connection to a remote resource is possible. Usually this will be a website on the internet, but it can be pretty much anything you want it to be, right? So it says here, the basic syntax for a ping is ping target. Perfect. What command would you use to ping the bbc.co.uk website? Well, let's try it. Ping bbc.co.uk. And we're getting replies. So that means we have connection to it. Perfect. Okay, ping this. So now, I'll tell you guys, there's a couple ways you can do this. You can use NSLOOKUP to find IP addresses, but I actually do this too all the time. I actually do use ping, and I just say oracle.co.uk. I just say, hey, ping it. Well, I probably misspelled it. MUIR land oracle.co.uk. Well, you guys spell Oracle right, Zach. All right. I do this all the time. I'll just ping it real quick and then Control-C to stop it and say, oh, okay, here's the IP, 217.160.0.152. Perfect, easy day. Now, that is actually a really handy tool. Some people will say that's dumb because it's like, oh, well, you could just NSLOOKUP and use your DNS and blah, blah. I get it. I understand it. But ping's easy for me. So one advantage I have, I think it's an advantage, some people think it's a disadvantage, is I did manual labor for most of my life, and I got into cybersecurity a little later. I'm 30 now, so I got into cybersecurity a little later in my life than what most people do. And that advantage helps me because I don't think of things the way some people do. I think of the easiest way to do something, regardless of if it makes sense. So whereas some people would go, well, your DNS will show you that, so why don't you NSLOOKUP, or why don't you look at your DNS to get, or Google's DNS to get the IP? I do things like this where it's super simple. I can type ping, it takes me 2 seconds, right? So it's kind of a good and bad because sometimes I take the long way, but it's easier for me. So All right, so which switch lets you change the interval of sent ping requests? So what we can do, same as always, we can type ping, or we can do the help page or the man page. And you can see here, we have the TAC I for interval. So there it is. What switch would allow you to restrict requests to IPv4? And you can see here, let's see, does it have it? I don't see it in there currently. So let's go man page, ping, and let's look for the TAC4. And there it is. Options, TAC4 uses IPv4 only. Perfect. And then we probably are going to have to stay in this page. So what switch would give you a more verbose output? I could probably just guess it's TAC-V, but let's see. See if we see it in here. And I can make this bigger for you guys. I don't know why I'm sitting there looking at it like that. TAC-V, verbose output. So boom, pretty easy, guys. Now, what I did there is I typed man and then ping the command. Man stands for manual pages on Linux. This is the attack box that TryHackMe uses, and typing man and then any command will give you a manual page for it, and that's what I use constantly. I'm going to be honest with you guys. I use it all the time, and it gives you a lot of information, but you can go through and you can really narrow down what you want to do. All right, so now we have traceroute. So what does traceroute do? Traceroute, or tracer in Windows, it traces the path to your target. Exactly what it says. So what does that mean? I'm not going to type it just so you guys know on here because it will give my router and all that stuff. But you can see traceroute is going to go on here, and it's going to tell you each hop that it takes. So what a lot of people don't understand when they get on the internet, when they start IT and cybersecurity, is it's not like you're pinging something and it goes from your router straight to their router, right? There's no direct fiber optic cable to your target. It wouldn't make sense. I mean, we'd have to have 5 million fiber optic cables coming into our house. So what does it do? It goes out here and it goes to your ISP, which is Internet Service Provider, and it's going to go to their hub, or their CO is what they call it, a central office, and then they're going to route it. They're going to switch it, blah, blah, and they might say, well, I got to go over to this central office, then this central office, then I got to go to Texas, and boom, boom, boom. And they're going to have protocols in place that do this, and boom, you can see like this one took 13 hops before it got to its target. Okay, so now that we know it takes a little bit and we got some hops, the reason it's important to know this is because what if it's not, your target says, yeah, you have permission to, to touch our network and send stuff, blah, blah, blah. But right before your target is a firewall that you have to break through. What if they don't own that firewall? What if it's their ISPs, or what if it's their parent companies or something? You have to know what you're touching. So keep that stuff in mind, guys. All right, so can you see the path your request has taken? Sure can. We'll try and traceroute it, but so it says traceroute, and they want tryhackme.com. Boom, and you can see we have. Luckily, we're on their VPN, so this is all their IPs. I forgot about that when I said I wasn't going to show it, then I did. All right, so what switch would you use to specify an interface when using traceroute? So what switch will we use? So let's just try traceroute without any. Boom, and we get some information. So we get, okay, so we have traceroute. Here's a syntax, how to use it, and we're looking for specify an interface. Well, usually when you see something like it says interface, look for a lowercase I here, and we have interface. Perfect. So there's your answer. So usually the switches are pretty easy to understand. They're usually pretty much what you'd think they'd be. When I say that, like, for instance, just change ports, TAC-P, right? I mean, that's kind of what you expect, especially if you've used a lot of Linux tools. They're all fairly similar as far as switches and things. What switch would you use if you wanted to use TCP SYN requests when tracing the route? Well, it says right there, capital T is TCP. Use TCP SYN for trace routing. One thing I think TryHackMe does really well is they actually word things almost perfectly to what the man pages and stuff are. So that way you see it and you instantly connect it. I think that's a really good tool to do. I think they really spend a lot of time doing that, and I really appreciate that. All right, lateral thinking. Which layer of the TCP IP model, so keep in mind TCP IP model, not OSI model, will traceroute run on by default? And it's the internet. It's running on the network layer, which is the internet layer here. All right. Networking tools. Who is? So if you guys are part of the Patreon, you know that I've actually we're creating a script on Patreon with all the Patreon members, and one of the things we're doing in there is who is a trace route. And what it is it's a scanning tool script that we're creating that does all these scans for you and submits a report to you, right? So that's a really cool tool. We're building it every week. We're building more to it, and this is part of what you're doing right here is stuff like this, the who is. So, all right, who is? What is it? All right, so here you go. Domain names, boom. The unsung saviors of the internet. So if you guys listen to Darknet Diaries, I'm sure you've heard that registering domain names has saved a ton of attacks in different ways. But the awesome thing about the domain name registration is you have to register it to someone. So what does that tell us? We can get information from that. So if you type who is in domain, so like let's do who is tryhackme.com. Boom, you can see it's registered to namecheap.com. Okay. So we know it's registered to them. We have a telephone number for them. Let's see. We have, the email is hidden. That's okay. Withheld for privacy. That's fine. The admin name is redacted for privacy. Okay. But they're not always redacted. They're not always. So as a hacker, if we do that, we already have an admin that works at the company or did. And then we also already have an email that is an admin for the company. And now we have the email scheme sometimes. So keep that in mind. That's stuff that you're looking for. So perform a who is search on facebook.com. All right. I guess I wasn't typing on that. Who is facebook.com. All right. What do we got? All right. So who is the registrant postal code? Or what is? I'm sorry. So what is the registrant postal code? 94025. So that means it was registered at this address. And now it's called Meta Platforms Incorporated. Okay. When was the facebook.com domain registered? And you can see it was registered in 1997. Wow. All right. So now perform it on Microsoft.com. So who is Microsoft.com? So when you register a domain, guys, what this does is places like Google and, Yahoo, anyone with a DNS server that's out there that's public, you can see like these are DNS servers or name servers. And those are going to now have this information stored in them. So now every time someone types Microsoft.com, this is where they go. And it gives IP number, everything. So you have to register all that so that it can actually be publicly available. Okay, so... Okay, if you fail to read the above instruction and consequently get the wrong answer for the next question, don't expect a helpful response if you report it as a bug. Okay. Which city is the registrant based on? And you can see we have Redmond right there, or based in. OSINT, what is the name of the golf course that is near the registrant address for Microsoft? So this was a fun little one, right? So you just go here, you type the address in. Where was it? 1 Microsoft Way, Redmond, Illinois, Redmond, Wisconsin, or Washington. I don't know off the top of my head. I think that's Washington though, not Wisconsin. And then might be that Bellevue's in Nebraska, so that's Washington. But anyway, so we just go to, let's see, 1 Microsoft Way, Redmond, Washington, and we'll say Google. That's not it. I had that saved. Google. So 1 Microsoft Way. Here we go. Redmond, Washington. And then we can just go here. And we can look for golf course. Now, golf course should be fairly easy. Bellevue Golf Course. And there you go. Bellevue Golf Course. Pretty easy, pretty quick. And now that also gives you a little taste of OSINT, which is a lot of fun. So what is the registered tech email for Microsoft.com? And admin at, that's the registrant email. We need the tech email. Here's the tech email. msnhst@microsoft.com. All right, so we've got some emails there that we could access too. That's pretty cool. Pretty good information, really. All right, so now we talked about domains. Ever wonder how a URL gets converted into an IP address? So this uses DNS, as we know. So when we're using DNS, we can go ahead and use dig, if you want, to try and basically get some information from DNS servers. So when you visit a website in your web browser, this all happens automatically. Yep, but we can do it manually with dig, which perfect. So let's see. We're currently most interested in the answer section for the room. Okay, so what is DNS short for? Domain name system. They told us that right up top. What is the first type of DNS server your computer would query when you search for a domain? So if you look up here, let's see if we can find the answer without having to do too much. Here we go. So this is how your computer automatically knows where to send it. So assuming the address hasn't already been found, your computer will then send a request to what's known as a recursive DNS server. These will automatically be known to the router on your network. So ISPs maintain their own recursive servers. So what that means, so companies such as Google and OpenDNS. So typically people use Google's, but you can use whatever DNS server you want. But what it is it's going to reach out to a default DNS server that kind of stores the internet on it, if you will, right? This isn't a specific server that you host or anything like that. So that's called recursive. All right, so what type of DNS server contains, so if you guys don't understand DNS simply changes a IP address into a name, a domain name. So when you type facebook.com actually goes and your computer goes, and gets the IP address from DNS, domain name system. And when that happens, it then goes to it. But like here, you see I have tryhackme.com up here, but that's still an IP address. So what DNS does is DNS will then send you to the correct IP address without you having to memorize it. Because without DNS, it's like having an address. Without it, you'd just be sending off a packet into the wild and hoping you hit something. The other thing to think about is without DNS, we'd have to memorize IP addresses for every site we wanted to go to. So think about that. All right. So here we go. What type of DNS server contains records specific to domain extensions? So .com, .co, blah, blah, blah. That's a top level domain. So that's just simply what it is. It's a top level domain. And what the difference is, the top level you can see here is that's like .com, that's .co, .uk. Those are top level, meaning like Facebook.com, not Facebook, /login/admin/ whatever. This is just the top level, the high level of it. It's not, you're not getting into the weeds, you're not getting the details. These are high level .coms, .co, .orgs, whatever. All right. Where's the very first place your computer looks? That's local cache. So what that is, your computer actually has a DNS on it, but the DNS is a local cache, meaning it's trying to see if you already have it in there. This is where DNS poisoning comes in handy, because what people will do is they will poison your cache. They will put something in there that says Facebook is actually this IP address, which is actually a fake website that they want you to go to. Now when you type facebook.com, your computer goes, boom, I know the IP address, sends you to the fake website, and next thing you know, you typed in your credentials on a fake website. You didn't mean to. That's when someone poisons your DNS cache. That's why you don't get on public Wi-Fis. That's why. One of the reasons. Okay, so research. Google runs 2 public DNS servers. One of them can be queried with IP 8888. What is the IP address of the other one? Quick Google search will tell you it's 8844. All right. If a DNS query has a time to live of 24 hours, what number would the dig query show? Well, this one's pretty easy, because let me see if I can pull up calculator here. All right. So we have 24. Wait, is that what it says? Yeah, 24 hours. And 24 hours times 60, because 60 minutes an hour, times 60, because there's 60 seconds in a minute, you have 86,400. So it's going to tell you how many seconds. So that's all it is. They're asking you basically what format's it in is really what they're trying to figure out. So Perfect, guys. That was pretty easy. I'm trying to keep this quick and light because this is an easy box. I'm going to try and start pumping these out for you guys, but I want you guys to understand the underlying concepts, but I'm not going to read this to you. You can read it. I want you guys to understand it more from a high level and understand what's actually going on rather than can you read and answer some questions, right? All right, so further reading, in terms of further information, feel free to reach out on the Try Hack Me Discord. Okay, there you go. And then obviously here's some self-study stuff, but this is very basic level stuff. This is introduction to networking. This isn't high, or this isn't low level. This isn't real deep in the weeds. This is just high level introductory networking. It's to start building a base as we go through this and start using the networking concepts to actually dig deep into these. So hopefully you guys enjoyed this. I tried to keep it brief. I tried to keep it light. Don't forget to subscribe if you guys like it, because we're going to be doing the entire cyber defense path, and we're going to be knocking it out quick. And then also don't forget to use code Stuffy24 at manscaped.com. And we'll go ahead, did I throw it back in here? Boom. Get you one of these. I'm telling you guys, it's a game changer. Makes a huge difference. And that trimmer just has saved my life. I'm telling you right now. So hopefully you guys liked it. Hopefully you guys subscribe. Hopefully you guys keep the momentum going. And hopefully one of you gets lucky and wins the giveaway today. So thanks, guys.